Hello everybody, today I can complete triangle proofs with additional tools by doing mini proofs with my givens and then using additional tools, VRIAS. So, you should have already watched the lesson or learned the lesson, addition, subtraction, property mini proofs, and isosceles triangle theorem mini proofs. This is all putting it together. So, number one, in fact, let's do number one. We're always proving triangles are congruent. Is it obvious which triangles I'm proving are congruent? It is to me. I see this blue one, and I see this green one. So, statements. Reasons. Start with the first given. QV is congruent to UZ. Given. Are those sides or angles of the triangles I'm trying to prove? Yes, that's a gift. We move on. VW is congruent to YZ. Given. VW, YZ. Are those sides of the triangles I'm trying to prove? No, but they're part of it. Since it's part of it, VW is part of VY, that's when I use addition or subtraction. Do I need more or do I need less? I need more. What do I need to add to VW to get VY? WY. What do I have to add to YZ to get WZ? WY. So what I need to add to each of them is WY. So I'm going to write WY is congruent to WY. The reason for those being congruent is reflexive property. And now that I have what I want, I add them together and I get what I want, which is VY is congruent to WZ, addition property. Now I need to show the addition. So I add the two small pieces. I added these and these. So I write or VW, VW plus WY equals YZ plus WY. So those three things together count as one. That's how we use addition property. Now I continue with my proof. I have two pairs of things because that whole thing counted as one. I move on to my next given. I've got YQ is congruent to WU, and that is given. That's a gift. That's the side of the triangle I'm trying to prove. I have three things. So now I can see the triangles are congruent. QVY is congruent to UZW. I got side, side, side. And now that I have the triangles are congruent, I can see any of the corresponding parts are congruent. Angle Q is congruent to angle U, and that is CPCPC. So it's really the basics, except now we're inserting the additional tools. In this case, addition property got inserted, and addition property, if you don't know how to do it, you got to learn the mini proofs first. All right, let's just take a look at one more, because there's really just two new additional tools. There's the isosceles triangle theorem and addition subtraction property. So number two, I'm always proving triangles are congruent. Is it obvious which triangles I'm proving congruent? It is to me. I got the blue and I've got the green. So statements, reasons. I start start with my first given. Angle ABC is congruent to angle ACB. The reason is given. ABC and ACB. Are these sides of the triangles I'm trying to prove? No. So, or angles, should I say, of the triangles I'm trying to prove. So, why did they give it to me? VRIASV. Do they have anything to do with vertical angles? No. R, do these angles have anything to do with reflexive property? No. I, do these angles have anything to do with an isosceles triangle? Yes. Oh, yeah. Since I'm looking for an isosceles triangle, I see it. And if those two angles are congruent, then the two sides opposite them are congruent, and those sides are sides of the triangles I'm trying to prove. So now I can state that AB is congruent to AC, isosceles triangle theorem, which states that in a triangle, congruent angles are opposite congruent sides. That counts as one thing for the triangles. I move on to my next given. I've got AD bisects angle BAC. That's given. I do a mini proof with that. That's angle bisector and angle bisector creates two congruent angles. So BAC, there's BAC. There are my two congruent angles. A must go in the middle for each of them. So I've got BAD and CAD. BAD and CAD. Now I have two pairs of things congruent in those triangles. I'm out of givens. I move back to my additional tools. V, there's no vertical angles. R, yes, there's reflexive property. AD is congruent to AD. Reflexive property. Now that I have three things congruent, I can state that triangles are congruent. Triangle BAD is congruent. Triangle BAD is congruent to triangle CAD. I've got SAS is congruent to SAS. And now that the triangles are congruent, I can state that BD is congruent to DC, CPCTC. So again, the additional tool was right here. ABC and ACB were not angles of the triangles we're trying to prove, but it did make this an isosceles triangle. And an isosceles triangle not only has two congruent angles, it also has two congruent sides. So I can state those sides, reason isosceles triangle theorem. That's it. I mean, those are the two new additional tools. There's also subtraction property, which is really the same concept as addition property. It takes practice. This is not an easy lesson. There's a lot of little pieces that go into this, and everything is broken up nicely for you, all those little pieces. If you understand all the little pieces, this lesson really shouldn't be bad. But if you don't understand all the little pieces, this lesson is not going to happen for you. At this point, practice, 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 and that's it for me.